Okay, what I want to do now is I want to give you a few examples of quadratic functions, and I want you to try and identify the axis of symmetry, the vertex, the Y-intercept, and the X-intercepts. Okay, so let's. I'm just going to arbitrarily make something up here. Let's say that it is 5x squared minus 9x plus 4. Okay, we'll see how this turns out. So first of all, let's identify the axis of symmetry. Now, if you remember how to do this, if you took your notes on the last video, then you can probably just pause this and do it right before I do it. But how do we identify the axis of symmetry? Well, it's at x equals negative b over 2a. All right, so in this case, b is negative 9. So that's going to be negative 9, because b is negative 9, and we've got to put a negative in front of that, so it's negative 9 over 2a. In this case, a is 5, so that's over 2 times 5. So that means negative 9 is 9 over, and 2 times 5 is 10. So at x, the axis of symmetry is at x equals 9 over 10. Now that's just slightly less than 1. 9 out of 10, 9 over 10, or 0.9, right? And so that's going to be, if this is 1 right here, it's going to be right before 0.1. That's going to be that vertical line. That's going to be the axis of symmetry. All right, so how do we identify the vertex? Well, the vertex is at the axis of symmetry. It's the y value, or excuse me, it's the xy value, and the y value comes from the axis of symmetry. So the vertex in this case is going to be at 9/10 and then some other value. And the way we get that other value is we plug our 9/10 in for x up here. So it's going to be 5 times 9/10 squared minus 9 times 9/10 plus 4. Now it's going to take a little bit of work here. We're going to have to work with some fractions, and that happens sometimes. How do we square 9/10? Well, that's 9/10 times 9/10. 9 times 9 is 81. 10 times 10 is 100. So we got 81 over 100. All right, so that means that this is 5 times 81 over 100. Then negative 9 times 9/10. Well, negative 9 times 9/10 is, well, we multiply the negative 9 times the numerator, because this is like negative 9 over 1. Negative 9 times 9 is negative 81. 1 times 10 is 10. And so it's negative 81 over 10. So we've got negative 81 over 10, and then plus 4. We've got to do one more thing here. We've got to multiply our 5. Actually, we've got to do a couple things. We're going to need to find a common denominator. 5 times 81. If you do that in a calculator, you're going to get 405. So we have 405 over 100 minus, now we need this to have a denominator of 100 so that we can combine it with the 405 over 100. So to turn 81 over 10 into a fraction that's over 100, well, we got to multiply this by 10 to get to 100, so we'll multiply the top times 10 also. So if we did 10 over 10, 10 times 10 is 100, 10 times 800 or 81 is 810. Okay, so now this is 810 over 100. And then lastly, we got to turn this 4 into over 100. Well, we're going to turn it into over 100 by multiplying by 100 over 100, right? And 4 times 100, that's 400 over 100. And now we're going to do 405 minus 810. That's negative 405 over 100. Then we're going to add 400 over 100. And negative 405 plus 400 is negative 5 over 100. This can reduce now, right? Now we could have reduced these a long time ago, but this will now reduce. 5 divides into 100, goes in 20 times, right? So this is 1 out of 20. So negative 1/20. Okay, so our vertex is at 9/10 and at negative 1/20. Okay, that's our vertex. All right, let me get rid of this. Now, our y-intercept is at 0, c, right? This is an easy one. Well, in this case, c is 4. So our y-intercept is at 0, 4. Okay? We're good there? All right, and now the x-intercepts. All right, to find the x-intercepts, we need to either use factoring. We have to set this equal to 0. So we're going to have 5x squared minus 9x plus 4 equals 0. And now we either have to factor, or we have to extract square roots, complete the square, or we got to use the quadratic formula. Now in this case, we can't extract square roots because it's not a perfect square on this side. We can't use the completing the square because we got a 5 up front, and this is not an even number. Therefore, we might be able to factor. Let's see, 5 times 4 is 20. Are there two numbers that multiply to 20 but add up to -9? Well, actually there are. It's -5 and -4. See, -5 times -4 is 20, and -5 plus -4 is -9. So we can actually do product sum grouping in this particular case. So we've got a -5 and a -4. So we're going to turn this into 5x squared minus 5x minus 4x plus 4 equals 0. Okay? Now we'll do the grouping. Put this here. We're going to turn this into a plus, and we're going to squeeze a negative in there. That's -4x. Now we're going to take out the greatest common factor. We can take a 5x out of here. 5x. That leaves an x here, and -5x divided by 5x is -1. Plus, now what are we going to factor out of -4x plus 4? We can factor a 4 out, right? But because this lead coefficient is negative, we're going to take a negative out. So it's going to be -4. And what is -4x divided by -4? It's x. And what's 4 divided by -4? It's -1. Equals 0. And now we have 5x minus 4 is one of our factors. Our other factor is x minus 1. And it equals 0. So now we just set each of our factors equal to 0. 5x minus 1 equals 0, and x minus 1 equals 0. We're going to add 1 to both sides. We're going to get 5x equals 1. We're going to add 1 here, add 1 here. We're going to have x equals 1. So we have one of our solutions, x equals 1. The other one here, we're going to divide by 5, and our other 0, our other x-intercept is x equals 1/5. And so we have identified the axis of symmetry, we've identified the vertex, and we've identified the y-intercept, and lastly, we've identified the x-intercepts for this quadratic. Okay? Let's do one more. Let's see here. All right. Let's do one that's a little bit easier, maybe. Let me think about this one for a second. How about 7x squared minus 42x minus 1. Let's do that. Okay? All right? So try to identify, I want you to pause it right now. Try to identify the axis of symmetry, the vertex, the y-intercept, and the x-intercepts. All right, so let's see if you got them right. The axis of symmetry is at x equals -b over 2a. In this case, b is -42, so that's -42 over 2 times 7. So that's 42 over 2 times 7 is 14. Well, what's 42 divided by 14 is 3. Okay? So we've got x equals 3. So the axis of symmetry is at x equals 3. The vertex is at the xy coordinate. That includes the axis of symmetry. So that's x equals 3. And then we're going to get the y value, we're going to plug 3 into the function itself. So we're going to get y is equal to 7 times 3 squared minus 42 times 3 minus 1. Well, 3 squared, that's 9, right? 3 times 3 is 9. 9 times 7 is 63. So we got 63. 42 times 3 is 126. Okay? So that's minus 126 minus 1. Well, 63 minus 126, well, that's negative 63. Minus 1, that's negative 64. So the vertex is at 3 and negative 64. All right, so we've got the vertex. Now let's identify the y-intercept. This is the easiest one, right? The y-intercept is at 0, c. And what is c up here? That's negative 1. So the y-intercept is at 0, negative 1. Now to identify the x-intercepts, we need to set the function equal to 0. So we're going to take 7x squared minus 42x minus 1 and set it equal to 0. Well, this does not qualify for completing the square. Actually, technically it does qualify for completing the square. I could do it, it'd be really a pain in the butt. I'd rather do the quadratic formula than complete the square here. But it doesn't qualify for extracting square roots. I don't think it's factorable. 7 times negative 1 is negative 7, and there's nothing that multiplies to negative 7 that adds up to negative 42. So we're going to have to use a quadratic formula here. So our A is 7, our B is negative 42, and our C is negative 1. So x is going to be equal to negative b, all right? So b is negative 42 plus or minus the square root. I'm going to need a calculator for this one. Hang on. All right. So it'd be negative 42 squared, which, by the way, is 1,764, minus 4 times a, which is 7, times c, which is negative 1, all over 2 times a, and a is 7. So now we've got x is equal to negative 42 is 42, plus or minus the square root of, like I said, this is 1,764, minus 4 times 7 times negative 1. Well, 4 times 7 is 28. 28 times negative 1 is negative 28. And it's minus negative 28, so that makes it plus 28. All over 2 times 7 is 14. And 1764 plus 28 is 1792. So now what we have is it's 42 plus or minus the square root of 1792 all over 14. And one of them will be plus and one of them will be minus. Now, you want to see something interesting here is we can actually break this apart. This actually becomes 42 plus and then 42 minus. I'm going to break up the fractions. I'm going to go 42 over 14 plus the square root of 1792 over 14. See, this is the same as this, okay, because it's a common denominator. So we could turn it into one fraction, or we can break it apart into 2 fractions. The other one is going to be 42 over 14 minus the square root of 1792 over 14. Okay, now, what is 42 over 14? Well, 42 divided by 14 is 3. So I'm going to put a 3 here. So it's 3 plus the square root of 1792 over 14. And again, this one is going to be 3 minus. Now I want to show you something. Let's go over to the axis of symmetry where x is equal to 3. This is going to happen every single time. Whatever your axis of symmetry is, your axis of symmetry is going to be, after you have divided by the fraction, after you have divided by the fraction, it's going to be that plus this. So in a way, it's a new kind of quadratic formula. It's almost like a shortcut in a way for the quadratic formula. Okay? But the reason this happens is, remember that the X-intercepts are always equidistant on the left and the right from the axis of symmetry. And so this is how far to the right and how far to the left. This is the same distance. 3 plus this number and 3 minus this number. Okay? In the next video, I'll try and do one where it's a whole number here, and you'll see what I'm talking about. And we'll do the quadratic formula. Okay? But here's a couple examples. These are things that you have to be able to identify.